Welcome back, everybody. Finishing up this last section for financial algebra, we're talking about the revenue and the expense in break-even analysis, excuse me. What we're really looking at is the profit equation. That's a pretty cool sounding thing, the profit equation. It sounds really powerful, and it really is. When we talk about revenue, we talk about expenses, we're really looking at what point we're making money, because that's why we're in the business in the first place. If we're selling uh, widgets, which is the standard economic or textbook answer. But let's say we're selling shoes. We've got this awesome pair of kicks that everybody likes. They're super comfortable. They last a long time, or maybe they don't. So we can sell more of them, right? Whatever it is that we're selling, we need to make sure we know at what point are we going to make money, and at what point are we barely covering the costs. And if we have investors backing us up, they need to know that too. We need to be able to put that information out there if we're gonna, go public in an IPO for our company and start having stock that's available out there. We need to know what point are we going to be making money and how are we going to get there. So in this setup, I've already set up some information. This is the same idea we had last time. I guess I could reference, we have again our break-even points, but we're really not concerned about those at this point. What we're really concerned about is this: profit, profit, the money. We want that money, and we want to know at what point do we start putting money in our pocket. If it's a small business, hopefully we're pushing that back into the company, and we can survive a little bit on the scraps that we receive after everything's paid off. But we want to be in the green or in the blue in this example here. So it's actually pretty simple. The profit minus the loss, I should say loss being expenses, not really loss. So maybe we should clarify that here. These are expenses. This is money we lose just to operate. Profit, this would be like, oops, this would be our sales, that money we make from selling something minus the expenses it costs to make it. The cheaper we can get our expenses, the better we're off. That's exactly Walmart's model is all their suppliers have to get to that point because they say I will sell you tons of this, or I will sell your product to tons of people, but it's at these requirements and this is the cost. So we have to then kind of haggle down our expenses somehow, hopefully not cutting corners, but that happens too, unfortunately. So what do we do to get that? It's quite simple. Algebraically, I have two equations. I have a revenue equation. We're using the same information from the last graph, so that means we have something like this still. And we have an expense, same equation again. So what we're looking at is we want to find what is our profit. So to do that, we simply take the equations and subtract. Understand, for subtracting off a negative, that is a positive. If I take away money I owe to somebody, that becomes money that I don't owe anymore, more money in my pocket. So algebraically, when we subtract revenue from expenses, that's what we're doing. So I went ahead and did that whole step for us here. Here's our revenue and our expenses all combined. You know what? We need a neutral color. We'll use black, right? That works. We have our revenue minus our expenses. This is our profit equation. In fact, we could calculate that by quickly putting that into Desmos. Let's see if I can find an open window here. Yeah, let's do this. Desmos, start graphing. I'm going to type in my new calculation, my profit equation, into Desmos. Again, I'm going to be substituting X in place of the p-value because my domain's already set up this way. That's the way Desmos likes it. I'm okay with that. I can accommodate their needs because they're going to make my life really easy here in a second. Done. Sort of. Now we need to be able to visualize this stuff. Technically, we could just go with it and find the halfway point. But what we need to know, see in our original graph, in the calculator side, the way we had it set up, we had this image right here, and we could go and find the peak simply by using math, analyze and say, what's our maximum? and we're looking at this one here, and it tells us the maximum is 30 bucks. But you notice expense is going down, and to determine if 450,000, I believe that's what it ends up being, um, is the most we can make when you subtract expenses. Is that true? We're going to make less here, but less expenses. Now, if you want to visualize it, if you ever did algebra, if you have had a decent algebra teacher or understanding, which slope is steeper? I feel like if you were to take a tangent line to this, it's steeper. That means this is going down at a much steeper pace, therefore the profit is going to go down faster than the expenses, ultimately decreasing total profit. I say revenue is going faster than expenses, not profit, sorry. Revenue is decreasing faster than expenses. So hopefully visually we can see that, but mathematically we want to prove it. So we're going to do that just here. Make a couple of modifications on our values. We don't care about y-axis being negative. It's just not important to us. But we're going to change this a little bit. I'm just going to keep doing what I did before. Add zeros. There we go. And we can look for the peak. And I don't know if I'm exactly there or not, but that's the setup for how to determine at what price we actually make the most profit. This value also can be found algebraically simply by taking your quadratic formula and putting it into this. I say simply, it's almost simply. Negative b, so negative 33,500 over 2a, which is negative 1,000. Those are going to cancel, and we're going to simply divide it by 3 zeros. We have 33.50. That is what we have here. We're good to go. Now what we would then do is take this and plug it back into both variable inputs, because that's the price, and that helps us solve for profit. Of course, if you have Desmos, why would you do that? I can just see it. It's right here. We're done. But we can calculate that as well simply by plugging it in. We're going to go and do that here right now. So we're going to take our original equation, and what I'm going to do is negative 500, and put a parenthesis for x, and we said 33.5 to the power of 2 plus 33,500 times 33.5 minus 238,000, and solve, and compare to this 33 or 32,3,112,5. So somewhere in that range. What do we have here? 323,125, 323,125, and we are good. We've got it. Again, you can just use Desmos. It's super helpful. A graphing calculator would also do it. We just have to recalculate the whole thing in here. We would just simply create another equation, negative 500x to the power of 2 plus 33,500x minus 238,000, and notice we would then simply take our analyzing the graph, looking for a maximum, referring to this graph here, and there it is again. There's a number of ways of doing this. Honestly, I would go with the best route of using Desmos. You can get that kind of stuff done on your phone. There are other apps that do this as well. The only challenge in this one is we had to get into the quadratic formula, but we didn't really, because when we set those two equations equal to each other, we just needed to find a difference algebraically between this value and this value and find which one gave us the most difference. A way to visualize it, I guess, if you could think just for a moment, and actually, you know what, let's just do another one over here on my other screen here. If we just thought about this for a moment and we were going and drawing a graph, this is not going to be perfect, I know. We could measure distances between the surfaces, between the curves, and look at which one had the greatest. So whether it be X, Y, or Z, we don't know. But whichever one has the greatest distance, that's the point at which we have profit. But you can see that would be kind of tedious. This way works so much more efficiently, graphing the equation in terms of the new equation by just setting them both equal to each other and solving. Oh, I just realized that's not shown, sorry. And just setting that up. So ignoring all this negative b, let's just erase all this stuff. Ignoring all this extra piece here, all we really need is this piece right here. That's all we need. Here, move that. And so that is the profit equation. That is 2-7 in our book, but that's the profit equation. It's a short video. I say it's short. It's not too complicated of a problem. You've already basically done it in the previous one. But that is how we do this. If you have questions, please again ask. I will be more than happy to assist in any way that I can. Just ask me. I'm okay doing that. That's my job. I'm a teacher. I like to teach. So best of luck going forward, and we'll see you again.